Hey everybody, my name is Subhi Dahbour. I am a second year student and I study industrial engineering in the German Jordanian University. Today, I'm going to talk about an overview of a very interesting and important subject, which is conductive polymers. Conductive polymers are very useful and beneficial materials that can be widely utilized in our lives. But before I get directly into the conductive polymers, I'd like to make a quick revision for a couple of things. First of all, let's talk about the electric current in general and how does it exist. Okay, as you can see in the picture shown here, there are three atoms with their electrons around them, and electric current is just the flow of electrons from atom to atom. Now I'd like to explain generally how conductivity differs between different types of atoms. Here we have two pictures of the atoms of metals and non-metals materials. The electrons of metals are delocalized because the outermost electrons in a metal atom are held loosely, allowing them to flow more freely. On the other hand, the outer electrons in the atoms of a non-metal are held more closely to the nucleus, as you can see here or here, preventing movement. Okay, while metals are generally the best conductors we have available today, we can't always get them easily. Processes like mining, shipping, or processing metals could be so expensive. So that leads us to think about an alternative materials that can effectively conduct current and aren't so expensive to reach. Okay, there are many advantages of the conductive polymers that make us tend to use them. Conductive polymers are attractive alternatives because they are lightweight, cheap, and functionally versatile. Now, before I talk about the polymers and how do they become conductive, let's explain first what are polymers and how do they synthesize. Okay, as you can see in these two pictures here, polymers are long chains. Polymers are long chains made of small repeating units known as monomers. A monomer is a molecule that can be bonded to other identical to perform a polymer. Conducting polymers are synthesized from their respective monomers using electrochemical, chemical oxidation, or interfacial polymerization processes. Now let's take a look at a polymer like polyacetylene. Polyacetylene consists of an alternating pattern of single and double bonds holding the atoms of the polymer together. As you can see in this picture, there's double, then single bonds, etc. This is known as a conjugated backbone. The first bond of each double bond is a sigma bond, and the second bond of each double bond is a pi bond. Along this backbone, the sigma bonds hold each atom together by concentrating electrons directly between them. The pi bonds strengthen the connection between their atoms by attracting the electrons above and below the plane of the molecule. This forms delocalized orbitals where the mobility of the electrons can be enhanced, as you can see here. This process is called doping. This process essentially changes the number of electrons to the atom by removing electrons from an atom or adding electrons to another atom. Removing electrons creates empty spaces in the outermost orbital of the atom, allowing the remaining electrons to move more freely, as you can see in this picture. Adding electrons forces the atom to create another orbital, as you can see here, and so long this orbital isn't full, the electrons have more space to move around and hop from atom to atom. As you can see in this picture. So as a result, the more easily electrons can move around from atom to atom, the more easily they can transport charges and conduct electrical currents. Now I'd like to show some future applications to the conductive polymers. First of all is the next generation bendable tablets and smartphones that have captured our imagination for years. Transparent touch sensor electrodes made from conductive polymers help next generation touch displays to become flexible, foldable, wearable, curved, and 3D shapeable, thereby combining the best of potential technologies. The second application is the supercapacitor. Supercapacitors have been focused on the development of new modified electrode materials with improved performance. The electrode materials have supercapacitors. Sorry, the electrode materials for supercapacitors have been classified into three categories: transition metal oxides, high surface carbons, and conducting polymers. Supercapacitors are also called electrochemical capacitors or ultracapacitors because of their pulse power supply, long cycle life, simple principle, and high dynamic of charge propagation. They have attracted much interest. That's all for today. Thanks for watching and goodbye.